Hi, hello, and welcome everyone to this last session of this past marathon analytics edition. We're really excited you can join us today for Dinesh Priyankara's session, stepping into data science predictive analytics. This is the last session of this back-to-back live webinars, and this session will be recorded and posted online after the event. All of you will be receiving an email letting you know once all the recordings for the event become available. My name is Eric Romero. I'm from PASS HQ, and I have a few introductory slides before I hand over the reins to Dinesh. If you require any technical assistance, please type your request into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions out loud to Dinesh. You're also able to zoom into the presentation content by using the zoom button located on the top of the presentation window. Please note that there's a short evaluation at the end of this session, which will pop up after the session ends in your web browser. Your feedback is really, really important for us for future events, so please take a moment to complete this. Keep learning year long. Visit pass.org and check out all the free educational resources available to PASS members. Connect, share, and learn. This PASS marathon session is presented by Dinesh Priyankara. Dinesh is an MVP for SQL Server for 13 consecutive years since 2006 and has over 18 years of experience on data-related technologies. He's an experienced professional and database enthusiast with skills in database management system and business intelligence. He's subject matter expert on SQL Server exams and has contributed for SQL Server 2012, 2016, 2017, and Azure Data Engineering exam development and job task analysis. And without further ado, here is Dinesh with stepping into data science predictive analytics. Dinesh, take it away.
Thanks, Eric. Hello, everyone. I believe that we have people from all around the world. So good morning, good afternoon, good evening. Since the interactive part has been done by Eric, I don't want to go through all these details again. So let me start this session by showing you the agenda. So this is what we have planned for this agenda. Everyone knows that this is going to be 45 minutes to 60 minutes max, and we don't have time for discussing all or everything related to data science and machine learning, but I'll try my best to cover the most important area related to data science, and I'll try my best to show the things you have to implement in terms of implementing a data science model. So we are going to talk about what is data science and what sort of things we can do with data science. That's going to be the first part of this session. Second part, we are going to talk about how we make sure that the data set we are going to use for data science is cleansed and ready for data science, ready for experiment. That's going to be the second part. Third part, let's talk about some of the techniques we can use for teaching the machine in terms of machine learning. So we are going to specifically focus on regression and classification because we don't have time for discussing everything. So as the last part, we are going to see how things can be implemented. I'll be taking a famous data set, but it's going to be a very small data set. And I'll show you some codes that have been written using Python to get the data into your environment and do the exploring, cleansing part, and then apply some techniques to teach the machine based on this data set, and let's evaluate it. And finally, if you're happy with the evaluation and if you feel like everything is okay, let's see how we can take it out and deploy for consuming. So that's the agenda, and let's see. Okay. So we are going to so you should see the poll now. There will be 2 questions, and please make sure you quickly answer those 2 questions. That helps me to determine whether we have to discuss everything in detail or we can spend less time on certain set of slides and spend more time on some other slides? Please go ahead and answer those two questions.
And so while everyone is answering those second question, for the first one, are you familiarized with data science? The first one, 71% said yes, but not in depth. 14% said no, not really, and 14% said absolutely. Now for this one, for this other question, have you implemented data science or machine learning before? 40% of the audience said yes, but not in depth. And 56% said no, never. So we got there like a 50-50 almost.
Okay.
So
Okay.
hopefully this gives you a good insight, Dinesh.
Yeah, thanks, Eric. Okay, so let's get back to the session. I believe that everyone can see the screen. Right, okay, so Eric, will you be able to confirm that part? Everyone sees the screen now?
I'm sorry, say that again?
Everyone can see the screen, right?
Yes, that's correct.
Not the ball, right?
Yeah,
Okay, fine. So we have the mix of audience. Some of you are really familiar with data science concept, and some of you have already implemented things related to data science, so which means you have done the coding part as well. But we have part of the audience is not much familiar with the data science. So I'll try my best to balance this, and I'm not going to spend much time on the theory part because most of you are familiar with the theory part. I'll try my best to spend much time on the demonstration part, even though some of you have already written some codes for implementing data science projects, so the solutions. Right. So let's start with this introduction to data science. I have taken two definitions from the web. I see a screen on my Eric, I'm sorry, like I'm seeing a screen on my window. I'm not too sure whether. Anyway, let me close it. Not too sure what is it. Okay, sorry for that. Suddenly, some pop-up appeared. That's okay. So, let's try to understand what is data science. So I have taken two definitions from the web, and as you see, both definitions talk about so both definitions talk about the similar thing. So this is how I understand data science since I've been implementing many data warehouse and BI solution. What we have been doing is we're trying to get some knowledge out of this data. We're trying to see some insight which we have not seen before. So that was a part of the data warehousing and BI. So are we talking about the same when we talk about data science? In a way, yes, but we are trying to do more thing with data science. If you focus on data warehousing and BI, we are trying to work with data and we are trying to do some analysis. We don't call this as analytics. But if you think about the data science part, we're trying to do more on analytics, not analysis. So, this is how we try to distinguish these two, area related data implementation or data related projects. But what you have to remember is data science is all about getting some knowledge or extract knowledge from your data set and see something which you have not seen before, or you use this data set for improving the business, predicting certain things that can be used for changing your business. That's how you need to understand the data science. Let's quickly go through a few set of questions that can be easily answered by the data science solutions. So the first one is, if you know about the data science, you have already, seen this question, heard this question. So because of that, I'm not going to spend much time on that. So let's try to understand these 5 questions quickly. So the first one is whether something is A or B. We are trying to categorize something based on some known categories, known classes. Good example is an email. So whenever you receive an email, you have already noticed that your email is getting tagged as a spam if it is a spam one. So mail is whether the mail is spam or not. That's this type of question. Another example, let's say we have capture details for human and we want to check and see whether this human is male or female. Likewise, if you want to find out the related category, that can be easily done with data science. That's one type of question that can be answered by data science. Second one is we have set of records, set of observation, set of record sets. We need to find some odd records out of all these records. Now, as you see, I have added pictures of vehicles. In addition to that, you can see a picture related to a flower. So if you think about all these pictures, the flower is an odd one. So we need to find an exceptional case. We need to find an odd case. So that type of requirement can be easily handled with or addressed with data science. That's the second type. So third one is really a famous one. We want to predict something. What would be the temperature for tomorrow? What would be my customer base in next quarter? What would be the sales for next financial year? That type of questions are being discussed with third type. Fourth one, again, many companies use this technique for grouping their record sets. For example, let's say we have customer record set and we want to do a promotion, but we don't need to do a promotion for all customers. We want to make sure that we pick the right set. So how do we determine the right set? One way is we can group the customer based on our known factors, like for example, based on the age, based on the gender, or else we can ask computer to, okay, group these customer set based on a different way. So if we want to get the grouping part, categorizing part using the second way, then we can use data science. That's the fourth one. Fifth one is another type of question that can be answered by data science solution. It's something like this. Now, if I go back to data warehousing and business intelligence, it's all about getting some information related to past. But what would be the present? What would be the the future ones? It's something like this. Let's say we see a problem and we have seen the problem. We have seen an issue as a part of the BI solution. But BI solution does not say that this is the activity or this is the action you have to take in order to handle that issue, in order to address that issue. But with this, if you really use data science, you can actually get the solution as well. That's called. So it is called as prescription. So you can get the prescription from the machine, not just the issue. So if you really look for something like that, again, you can use data science. So these are the types of question we try to get answers from data science solutions, or we try to handle with data science solutions. Now, I had this question, like I've been implementing data related projects for a long time, years. But earlier, of course, like I didn't start with anything related to data science or machine learning. But whenever everyone started talking about machine learning, data science, I wanted to make sure that I know how to implement, how to experiment with data in order to support the business. So I had to find what sort of skills I have to acquire, what sort of things I have to study. Now, generally, in order to make sure that we know data science well, we talk about these 3 areas: computer science, IT, maths and statistics, and domain knowledge. Computer science is all about you should know how to write codes, how to use data set. You should be familiar with the database management system, tables, records, things like that. Otherwise, you will not be able to work with data. So that's one skill set required for working with data science projects. The second one is math and statistics. Earlier, it was a sort of major obstacle, but now with the modern implementation, modern techniques, you don't need to worry much, but it doesn't mean that you can skip this part. You have to have the knowledge, good knowledge on math and statistics, but you can implement some data science projects, or you can work with some data science implementation without knowing much related to maths and statistics, but it is up to some extent. Just remember that part. If you want to go into deeper and if you want to implement advanced solutions, yes, you have to have this math and statistics knowledge. Third one is the most important part, the domain knowledge. If you do not know the business, even though you have mastered computer science and math and statistics, you will not be able to do a proper implementation. I'll give you a quick example. Let's say you're working with a data set that has the age column. So you want to determine whether age column has to be taken into your experiment or not. So how do you determine? So you should know whether age property or the field is really important to your business or not. So if you do not know about that, you can't just take it out, or you can just take it in and continue with the experiments. That's why we say that all these three skills are really required for implementing data science solutions. Right. How do you start with data science solutions? So just remember, data science solution is all about teaching the machine. You'll be passing some examples to the machine, experience to the machine, or in data science world, we use the term called observation. So you just pass some experience, observation to the machine, saying, here, these are the records we have, just study it and then try to find some patterns using these data sets. So it's all about educating the machine with some samples. So machine will study this based on the instruction we have given. And then once the studying part is done, machine will say, okay, I'm ready for it. Once we know that machine is ready, we just can't promote the machine saying, okay, you are really good at this work. We can hire you, or we can use you for determining or improving the process. We have to test the machines. So we have to do some testing on his the knowledge, and if you're satisfied, then we can promote the machine saying, yeah, you're ready for this, and we can use your knowledge for improving the business. So that's what we do as a data science. So how do we actually implement with, or actually do that as a project? So there are multiple standards, there are multiple practices available in this world in order to implement a data science solution. But this is the most famous, most accepted practice for data science, which is called CRISP-DM. So you can see the term data mining with this term or with this the process. So this process starts from understanding the business, and then you need to get the data into your environment and study the data. You need to check and see whether the data set is really good for this experiment or not. If not, you have to work with the data set, and you'll be cleansing it, you will be removing certain set of things, you will be applying some business logic, you will be doing various type of transformations, and finally you will be making sure that data set is ready for the experiments. So that's those processes or steps are discussed with the first three items, like business understanding, data understanding, and data preparation. So once the data set is ready, then you are going to apply some mathematical operations or various type of computer operation to educate or teach the machine. Once you feel like, or once the machine is ready for all this modeling part or all this, let's say, studying part, we can test it. So once the testing is done, or once the evaluation is done, if you're happy with the result, yes, we can deploy and we can start consuming it. And just one thing you have to remember with this process is you cannot just complete a machine learning a solution by completing these steps. Why? You have to go through all these steps again and again. It's something like this. We study something and we educate ourselves and we say that, okay, we are ready for that. We know this stuff. But we know that, after some period, we have to study again because there are new things. So same concept, you need to make sure you keep on teaching the machine. So which mean after certain period, like multiple days or couple of days, couple of weeks, couple of months, you have to go through the steps again because you have a new data set. You need to take that data set, do the preparation part and retrain the machine and evaluate again. So that's the process we have to practice if you are planning for data science solution. Let's talk about two types of categorization that can be used for talking about data science. We're not going to discuss all these things in detail. So we have supervised learning, unsupervised learning, and reinforced learning. Let's focus on supervised and unsupervised. But again, we'll be talking more on supervised because that's what I have used for the demonstration. So supervised learning is something like this. You're going to teach the computer with both inputs and outputs. Let's try to understand inputs and outputs. Assume that I have a customer data set. So it has properties like name, address, things like geographical area, and monthly income, whether the customer is married or not, whether he has his own house or not. Likewise, large number of characteristics explaining or describing the customer. Plus, let's say there's a column called credit limit. So the credit limit that have been given for the customer. Assume that we need to create a sort of application that can be used for determining the credit limit for future customers. So if a new customer comes in, I capture all the details like the name, monthly income, whether this person is married or not, things like that, and I want to pass that into the computer. And computer must say that, okay, the credit limit should be 10,000, credit limit should be 15,000. So that's the output I expect from this application. So if I want to get something like that created, I can use supervised learning. So I'll be passing a data set that has both input and output, which means I have all the characteristics of customers and the outputs, which mean the credit limit attached or the tag to this customer. So all these data set or the records in this data set are based on old customers. That's we cannot use new customer details because we don't know the output, or we don't need the credit limit. But if we can take all records which have inputs and outputs, we can pass it to the machine and ask machine to learn about it, study it, and find the relationship between inputs and outputs. Once machine says, okay, I'm ready, I have the formula, and give me the input, I can predict the output, then we can evaluate it, and if you're happy with it, we can promote it as a trained model or educated machine, and we can use it as a part of the application. So that's supervised learning. So just remember, supervised learning requires both input and outputs. But unsupervised learning is all about giving something to the computer, saying everything is an input, take everything, study it, and give us some sort of output. So unsupervised learning has no output in terms of or when you give experience or the observation to the computer. For example, we talk about promotion. So if I want to do a promotion based on customer data, we don't have a specific column saying, this customer has been used for this promotion or that promotion. We'll be just giving all records to the computer. So the computer will go through various columns or the features or the variables and try to figure out the values related to these features. And then it will come out with, for example, grouping, clusters. So it just produces an output without knowing what to be produced. That's unsupervised. So remember, supervised learning, we need to pass both inputs and outputs, but unsupervised learning will be just passing in the input, and computer will give us an output based on the instruction we have given. So I'll quickly talk about reinforcement learning as well. This is more on the prescriptive analytics. Not only that, like all we do is we just ask computer to study something and then continue with some sort of operations, but we never said that computer has reached the target. So it has to continuously learn based on the experience and then try to achieve the target, something like that. Okay, so let's talk about more on the supervised model. So this is how it works. So assume that this is the customer record set I have, and this X represent all inputs, Y represent the output. In this case, X1, let's take it as the income of the customer, X2, let's take it as something like date of birth, X3, whether this person is married or not. Likewise, we'll be having large number of X's. We call them as variables, features, columns, fields. You can name these things as you want. But why is the credit limit? That's the output. Remember, this is supervised. We have to pass both inputs and outputs. So we'll be passing this to the computer, and we'll ask computer to study and find a pattern or the formula. So computer will say, okay, I found the pattern between all inputs and the label or the output, and I'm ready for testing. So how we are going to test it, or how we're going to use this? We'll be passing inputs now without passing output, or without passing the credit limit in this case. So computer will say that, okay, this should be the credit limit for this customer. So that's how supervised model works. There's another categorization in terms of machine learning techniques. There are large number of techniques, but we'll take few because we are going to talk about classification as a part of the demonstration. So we have classification, regression, clustering, and association analysis. So classification is we have talk about it. So it's all about identifying the class related to this observation, this record, something like determining whether the mail is spam or not. Regression is predicting numeric values. Clustering, as we discussed, is all about the grouping things. Association analysis, I'm sure that you have seen it. This can be heavily seen with the retail industry. We're trying to couple some items in supermarkets and try to increase sales. So this is another way of categorizing machine learning or the data science. Okay, so the main thing is making sure that data set is ready for data science experiment. So how do we make sure that it is ready? We need to go through the data set. We need to check and see whether data is okay, cleanse, and no incomplete data, no noisy data. There are no inconsistencies. We have to make sure that data set is well prepared. So how do you do it? If you're using, let's say your data source is relational database, in that case, in my case, I prefer to use SQL itself for doing, transformation, cleansing, preparation. But you cannot do everything using SQL. You have to use some other languages like C#, .NET, or Python, or R for doing some sort of cleansing. But if the database, if the data source is relational, try your best to use SQL, because SQL is optimized language for working with relational data. But if you're going to work with unstructured data, semi-structured data, of course, you will not be able to work with SQL. You have to use languages like Python and R. And the other thing is, you have to make sure you don't have unnecessary columns or the features or the variables. You don't have or you have not taken unnecessary records or observation examples. And if there are missing values, for example, let's say there's a column called age, and we are working with the customer data set. There's a column called age, and not all records with age have been filled. Like there are some null values, there are some missing values. So how do you treat these missing values? One way is we can take the entire column out, or we can take records out, or else we can replace this missing value with some other values. So how do you determine? You have to explore the data. you have, in this case, you have to explore the age column and check and see whether what would be the range for this age, whether we have age range starting from 20 to 40, 20 to 60, something like that. Do we have exceptional cases, like whether we have values like 510 or 100, 200? So you need to check all of these things. So based on the result of your exploration, you might be replacing this missing value with your own value, or you can decide, say, okay, I'm going to replace all my missing values with 20, 25, or else there are some techniques like you can take the mean of age or median of the age. It's all based on the result of the exploration. So likewise, you need to treat all these missing values, errors, outliers, duplicates, all those things have to be handled before you take it to the experiment. In addition to that, we have something called feature engineering. You have to work with the features. You like, generally we remove columns, remove records, add records, add additional columns, things like that. But in data science practices, we do some sort of complex transformation by analyzing the column, and then we try to convert that column value into something else. And you're going to see something related to feature engineering as a part of the demo. In addition to that, we split the data set. So why we have to split the data set? We are teaching the computer using set of records, and once the computer is ready, once the computer has completed the study part, we need to test it. So in order to test it, we need to have another set of records. So that's why we split the data set. If you have 1 million records, generally we take 700,000 records for test the training and 300,000 records for testing. So you need to make sure you prepare the data set, everything is cleansed, ready, and then you split it, and you take the first part, which is for the training, and then you take that data set through various type of mathematical and computational algorithms, and then if you are satisfied with the operation you have done with the training set, you take the test set and evaluate it. That's what you have to do. So that's how you have to work with an experiment. So if I summarize this process, it's all about getting the data set, split that data set based on the percentage or the ratio you prefer. Let's say 70% of the data set is going to be configured or used as a training set. You take it, and then you do all sort of transformation, pre-processing. This is where you are going to see various adjustments for your columns, values, records, and things like that. And you might be adding new columns, you might be getting rid of certain set of columns. So that's going to be feature engineering. And once the data set is ready, you'll be applying some machine learning techniques, something like classification, regression, and you're teaching the machine by passing certain set of instruction. And once it is okay, once that part is done, you are going to test the machine using your test data set, which is the 30% of data set if you have taken 70% as a training set. And if you are satisfied with the test result, you'll be promoting this experiment as a predictive experiment, or you can call this as trained model. And then you can pass new inputs to determining or predicting the output. So this is the simplified machine learning process. Okay, so we have talked about classification and regression. This this section has 2 slides explaining regression and classification. I don't want to spend time on this now because I explained what is classification and regression. Let me skip these 2 slides and okay, let me explain this part. Now, we know that once the data set is ready, we need to apply some mathematical operations. This is where you apply machine learning algorithm. So which algorithm is best for my solution, best for my experiment? There is no hard and fast rule saying that you have to use linear regression or decision trees or random forest for an experiment. You have to first design the machine learning technique, whether it's regression or classification or something else, and then you need to pick one of the algorithms. Like, rather than picking it randomly, you have to know, you have to have an idea on these algorithms. So let's say you're trying to predict a numeric value. In that case, you'll be taking linear regression and then test your data set, or test or do some experiment with this linear regression. If you're happy with the result set, you can, finalize it and then promote it as a trained model. If you're not happy with it, you can try out with another algorithm. That's how you need to do the experiment. So there is no rule saying you have to take this one or that one. Take one, check it. If you're not happy with it, take another one, check it again. Then you can compare the previous result set and the current result set, and then you can pick the best. And let's say you pick the second algorithm used for the second experiment, and then you can finalize with the second one. That's how you complete your machine learning implementation. Right. So let me start with the demo. This is what I'm going to do. I'm going to work with, I'm going to show you how to do the classification. Even though I'm showing images of vehicles and all, I'll be working with a data set called German credit data set that has customer data and tagged with whether the customer is a bad customer or good customer based on the payment they have done, on the how customer have settled their credits and loans, things like that. So, but why I have added this slide, just to explain you that you need to make sure your data set can be split properly, and when you split it, make sure both two data sets, like one data set becomes two data sets, so both training set and testing set has proper balanced data set. You need to make sure that you have certain, like for example, let's say in this case, let's say we are trying to identify whether the vehicle is a car or not. So you need to make sure, images of cars in both training set and testing set. So if you're going to talk about customer credit data set, you need to make sure training set has both bad customers and good customers, and testing set also has good customers and bad customers. Okay, so this is what I'm going to do. So let's say we have a customer like this, and this is what we have recorded. So this customer has come to the bank or some financial institute and asked for a loan, and bank has given the loan, we given the credit, and we have certain characteristics recorded, like credit history, purpose of the credit, amount asked, age, things like that. And finally, after some time, we have marked the customer as a good customer or bad customer based on the payments or the settlement related to the credit. So for some reason, if customer has not paid installment properly, or if the customer has not settled the credit properly, then customer is going to be marked as a bad customer, or else customer will be marked as good customer. Sometimes we replace these values with codes, but it's completely up to you whether you are going to use values as it is or codes. You can handle it with the data science experiments. But what we have to determine is this: how do we determine this bad customer, yes or no, based on other characteristics? For example, computer has to find a formula for determining whether the customer or the record submitted indicates a bad customer or good customer by reading the values for credit history, purpose, credit amount, and age, things like that. So once this formula is ready, we can use this formula for passing new inputs and determine the output. Now, in order to do this experiment, we just can't use one customer, so we have to use large number of customer. That certainly increases the accuracy of our experiment or the model. So finally, we'll be ending up with a formula like this. How do we know whether computer has done the studying part well and computer is intelligent enough for predicting now? So there are various techniques, multiple techniques for determining whether the computer has enough knowledge for predicting. I'll quickly explain how we generally use this. We don't have time for discussing in detail, but I'll try to explain it in sort of high level. So let's say we have taught the computer by passing training set. So now computer has found a formula which can be used for accepting, which can be used for taking inputs and predicting the output. Okay, so let's take the example we have been discussing, customer credit data set. So now we are going to test the computer. We'll be passing the testing set, not the training set, testing set, and computer says that, let me plot it. Computer says that some of the customers are bad customers, some of the customers are good customers. So how computer determines whether the customer is good customer or bad customer? Let's say we are looking for value like, we're actually looking values like true or false, but let's say we are looking a value between 0 and 1, and if the value is greater than 0.5, we take it as true. If the value is less than 0.05, we take it as, the computer takes that value, computer takes that false. So this part indicates bad customers because true values are bad customers, false values are good customers. So we all these purple circles are test records. So we have passed certain set of records, and computer says this customer is a bad customer, this customer is a bad customer. Likewise, this section represent bad customers, this section represent good customers. But we know the actual value or actual status of the customer because all these are old records. So we can plot actual status as well. So green tick indicates bad customers, cross indicates good customers. So if you take this part, the values above 0.5, if you take this part, computer says all these are bad customers. And computer has actually determined or predicted 4 out of 5 properly. So all these are true positives. We consider all these are true positives. And if you take this part, computer says these customers are good customers. And you can see the cross is the actual one, and out of 6, 5 have been properly identified. So true negatives. So we don't need to worry about true positives and true negatives, but we have to actually focus on false positives and false negatives. False positive says that customer is a bad customer, but actually is not a bad customer, he's a good customer. So you need to check this value, how many false positives are there with your algorithm or with your model, and whether it's small number or large number. In this case, you can decide whether you can accept large number of false positives or small number of false positives. But let's go for this part as well. So this indicates false negatives. That means it says customer is a good customer, but the reality is a bad customer. So if your experiment, if your model predicts large number of FNs, it is not good for the company. Why? It says most of the customer in this part, it says customers are really good, no issue, you just grant the credit. But the reality is these customers are, these customers are bad customers. So you need to, in this scenario, you need to make sure you don't see much on false negatives. You can reduce this part as well, but considering this scenario, you need to focus on this. But it depends on the scenario. You might experience a situation where you want to see less number of false positive, not false negative. So based on the scenario, you need to determine. So that's one way of determining the accuracy of this experiment. In addition to that, you can adjust the threshold and check these values again. But let me plot all these things into a matrix like this and show you these formulas. We have accuracy, precision, true positive rates, and false positive rates. So we can calculate these measures based on true positives, false negatives, and true negatives, and see whether this is really good. The model is intelligent enough for putting into production. So we check the accuracy. Accuracy means it doesn't say that, it doesn't talk about the accuracy of the model. It actually talks about how things are properly classified. Okay, so you should see a number between the 0 to 1, which means like, if you see something closer to 100%, that indicates it's sort of good, but you should not see something like 95, 99%. If you see something like that, something wrong with your one. So just remember that you're not trying to train the machine for predicting 100% accurate results. Okay, so that's something you need to remember. In addition to that, we have precision, true positive rate, false positive rate. So based on the scenario, you will be determining the values or required values for these. We actually take this true positive rate and false positive rate and plot it to a chart like this to determine something called AUC, area under the curve. The best case is actually the line start from 0 and it goes straight up and stays in this line, but you are not going to see something like that with the real world scenario. But if you're seeing a line like this, you can actually accept it. So this is how you determine it. And let's see the data set. This is what I'm going to use. This is the German credit data. I'm not showing all the columns. So this has customer information. This is the customer ID. First column is the customer ID, and all other columns are the characteristics of customer. And the last column is whether the customer is a good customer or the bad customer. So if you see 1, that means it's true. So that indicates the customer is a bad customer. So I'm going to consider this as the label or the output, and all other columns as input. Right. So before going for the next slide, I'm going to open the Python code I have written for this, and I'll show you how to take this data into my Python environment. So I'm going to use Jupyter Notebook for doing this experiment. I believe that most of you are familiar with Jupyter Notebook, and most of you are familiar with Python. If not, just remember Jupyter Notebook is one of the tools used by many people who work with data, specifically on data science and machine learning projects. And Python and R are the most famous language for this. So let me open my code. So this is my notebook, and I have multiple cells. As you see, I'm importing some libraries. We don't have time for discussing all of these things, but if you have a question on the code I have written, we can discuss offline. Okay, so I'm importing some libraries, and let me execute that part, and then I'm import the data set. Okay, so if you're not familiar with this syntax, these commands, do not worry about it. Just try to understand the process. So I'm going to get the data set into my environment. If I execute this code, I'm getting the data. So this is what I'm going to see. So I can see columns. I can see my last column, which is the label. And since I'm executing credit.shape, or this is my data frame, and if I try to get the if I try to call the shape, I'll be seeing a result like this. It says 1000 rows and 22 columns. Now, since we are marking this as the output, we need to check whether this output column has sort of balance labels. Now, that's why I'm going to execute this part. So let me execute. I have already executed it, and that's why you're seeing the result. So as you see, there are 700 false values and 300 true values. So that indicates there are about 700 good customers and 300 bad customers out of this 1000 record set. So it is sort of imbalance. You should not see something like that, but in most cases, you'll be seeing a result set like this, specifically in a scenario like this. So if you want to adjust it, you can take some records out and adjust it, or else if this is the reality, you have to accept it and continue. So since I have loaded my data set into credit data frame, I'm going to take this label column into an array. So I'm going to call that array as label, and this command takes the last column from my data set and put it to this array called labels. So let me execute it. Done. Okay, So let me go back to my presentation again. I have the data set which is called credit, which has all my columns, and I have taken the last column, which is my output or the label, into this labels array. Let me go back to my presentation. Now I can see multiple columns. We always prefer to work with numerical value, and but when you take a data set, you're definitely going to see categorical column or some columns that have multiple categories, something like credit history, something like purpose, something like gender, something like let's say customer type. So rather than just passing these values as it is the machine learning algorithm, we can convert them into a suitable format. Then the machine learning can efficiently work with this. So this is where you see feature engineering. I'm going to show you a very small thing on this. What I'm going to do is I'm going to convert these categorical columns into integers. So how do I convert them into integers? I can use multiple techniques, but this is the technique I'm going to use. So let's say we have a column like this, credit history. It's a categorical column. I don't want to take these values as it is to my machine learning algorithm. So all I want to do is convert them into integers. So I need to find a way of converting them into integers. So you can see how values have been generated. So first thing is we need to find out number of unique values in this column. For example, first one is credit account, other non-bank loans. Second one is current loan paid. Likewise, there are 4 unique values in this column. So we are going to use those 4 unique values for converting these into numeric. So this is how we are going to see it. The first one is 1, and you are going to see, you can see the third record is same as the 1. That's why we are seeing 1 for this and 2 for this. So that's how it has been converted. But if you try to pass these values to machine learning again, there will be a sort of issue, because machine learning algorithm might takes 4 as a sort of higher value, 1 as sort of small value. So there can be a situation machine learning shows some bias on this, or it consider this as more higher or the prioritized value. So we have to make sure that machine learning algorithm or the machine does not think like that. So we are going to convert this as a dummy variable. We call this as dummy variable. We are going to convert this 1 as 5 values. Why we are converting this 5? Okay, I forgot to tell you, like even though we saw 4, there are 5 unique values. We are not seeing the value 5 because we are not seeing that category in this set of records, but there are 5 values. So since there are 5 values, we are going to convert these numeric values into 5 values. So it is not just going to be an array, we are going to convert it as 5 columns. So you can understand how these values are getting generated. 1 will be represented as 0, 1, 0, 0, 0, and 2 will be 0, 0, 1, 0, 0. So same pattern will be used for all other values. So we'll be converting all our categorical columns like this. So if you have 5 categorical columns, and these 5 categorical columns will be converted to multiple columns based on the unique values these columns have. Okay, so let me show you how I have done this part with the Python code. I'm checking the I'm checking the credit history column to find out unique values. And when I execute it, I can see 5 unique values. That's why we are seeing 5. And then I'm going to use label encoder for converting them into integer. I'm going to instantiate an object called encoder which can be used for converting them into integer. You have to use fit method for applying it to your record set, and then finally you use transform method for converting values to integer. So when I execute this, this is the result that I'm going to see. So the first value has been replaced with 1, second value has been replaced with 2. But remember, this has only 1 column. As I told you, if I go back to this, I need to convert this 1 as 5 columns now, 2 as again 5 columns with different set of values. So that can be done by applying something called one-hot encoding. Again, there are multiple ways of doing this, but I'm using one-hot encoding. I'm instantiating that object and fit it and transform So once it is transformed, I'm going to see something like that. I'm not listing all the records. You can see the first value has been converted to 5 columns. Okay, right. So I have written a method to convert all my categorical columns, all these columns, to a format of 2 columns like this. So all my categorical columns, all these categorical columns like credit history, purpose, gender, status will be converted into columns like this, and then we are forming a data set that contains all these records. Okay, so this is what I'm going to do. Let me iterate all these columns and pass column by column to this method, and then form an array and take the array and put it to a data set. You can go through this data set or the code later to understand this code, but let me execute this. Once I execute it, I'm ending up with 1000 records and 42 columns. If I scroll up, you can see I have only 1000 records and 22 columns, but now I have 42 columns. Why? New columns have been introduced because of the technique we applied. So this is how you convert categorical columns into dummy variables. Not only that, we have numerical values as well, something like this. So these values have to be normalized. Why I'm saying we have to normalize? If you have, let's say, 5 numeric columns in your data set, you need to make sure that all these values are in a single range. If you take loan amount, it is always a big number. If you have an age column, it is going to be a small number. So there can be a sort of situation where machine learning or the machine thinks like, okay, it has to give more, it has to consider loan amount as a more prominent one, and it has to consider less with the age because of these values. Considering that fact, if we can convert all these things to one scale, that would be really good. So what we do is we apply some function in order to convert these numeric values to sort of similar range. So we call this as rescaling. So that's what I do with this. So I'm using all these columns, numeric columns, and then the give me a second. First, what I'm going to do is I'm going to add these columns to my feature data set. So my feature data set is this, which has 1000 rows and 42 columns based on my categorical variable or the features. And I'm going to add these columns to this first. So once it is executed, I can see 46 columns now. Earlier it was 42. After adding these 4, now we have 46 columns. Before normalizing or before rescaling, I'm going to split this data set. I'm going to use a different there are multiple techniques for splitting. So I'm going to create an index. So the first part of the first column of the index represent the training set. Second part of the index or the second column of the index represent the testing set. Do not try to understand this code. You can go through the code later. All I'm trying to do is splitting this 1000 record into training set and testing set. That's done. And once it is done, I'm going to apply standard scaler for scaling. So let me execute this part now. As you see, I'm not applying the scaling for all columns, only the last 4 columns. So this is how you, this is called slicing with Python. This is how you refer certain number of columns. So if you take one record now, you have 42 columns, and all these values from this to this represent categorical column, and these 4 values represent numeric columns, and it has been scaled. It has been rescaled or normalized. Right, now we have our data set, and how do we apply machine learning algorithms? So you can apply one and see, you can check it. We don't have time for applying multiple techniques. So I have written a code for applying one algorithm called logistic regression and test it, and I have another code for applying decision tree classifier algorithm and see. So let me execute this part. So this is how you do it. You instantiate this, you create the object for your algorithm. And then you call the fit function by passing training set and training label. So this is training inputs, this is training output. So when I execute this part, computer will try to find or go through record sets and try to find the formula, the relationship between inputs and output. So once it is done, we can actually test it. So this is how I evaluate it. I'm going to get the probabilities for the label is 0 or 1. So this code helps me to determining whether the label the predicted label is 1 or 0. So this part actually represent the true part. The first part represent the false part. So second part represent the true part. I can get the true false values or the label value by calling this method. I have written a method to pass this value with the threshold. So I'm passing the threshold as 0.5. If this is greater than the 0.5, I'm taking it as 1, which is true, which is bad customer. If it is lower than 0.5, I'm taking it as a good customer, right? And I'm forming a result set, which is called scores. And if I print the real values and the predicted value, you can see it is not 100% matching, but most of the records are matching. So in a way, it is good, and I can determine true positives, false positives, things like that. Or I have written a method for determining all of these things. I can pass my test data with my scores, and I can see true positives 166 and true negatives 41. So we are okay with these two, but the most important parts are false negatives and false positive. In this case, considering this scenario, we have to focus on false negatives. So we can go through all of these things again and again. We can scroll up and make changes. We can try out the different algorithm and check these values are okay. If I'm happy with these things, I can use something like joblib or pickle for saving this. So this is how I save the model for future consumption. I can execute and it is getting saved with this file in my machine. And if I want to predict again, I can call it by calling load method and get the model loaded and pass the data set. So let me call this, and I can call predict. Now you can see I'm using the loaded model. I call the predict and I'm passing all inputs. So computer will accept this input and predict the output. So this is how you use or consume the predicted model. Right. So that's what I have to show. Unfortunately, we have no way of going through details of these codes, but I think I have already spent 1 hour for all of these things. And if you have any question, so this is what we did. Let me see. If you have any question, I can spend a couple of minutes more.
Thank you, Dinesh. So we'll just give our audience a couple minutes, seconds to type their questions if there's any. I did wanted to remind everyone, we are uploading all this PowerPoint slides
Eric, I cannot hear you.
section. So yeah, if you're lots of you have in previous sessions also they
Eric, I'm sorry, I cannot hear you.
Thank you everyone for attending this session and for attending if you attended one of our previous sessions in this marathon. Have an excellent rest of your day and stay tuned for the recordings. Goodbye, everyone.
Okay, thanks everyone. Bye.
Thanks, Dinesh. Goodbye.